Before we discuss this problem, let's think back to this note that we just looked at. We were talking about when is the limit of f of g of x equal to f of the limit of g of x. And we decided that that only happens when f is continuous at the point x equals the limit of g of x. We're going to use that in the proof of this problem. We're making the assumption that g is continuous at the point x equals a, and f is continuous at the point x equals g of a. And we're going to show that the composition f composed g is continuous at x equals a. All right, the first thing we're going to do is take the limit as x approaches a of this composite f compose g of x. Now stop here for a second. In order for this to show that this f composite g is continuous, what we've written here, the limit, is eventually going to have to be equal to f composite g of a. That is the definition of continuity. So that's where we're headed, but we have to be careful to validate every single step. Let's continue. This is equal to the limit as x approaches a of f of g of x. That's the definition of f composite g. And that's equal to f of the limit as x approaches a of g of x. Now, why is that true? That's a pretty bold statement. It's true because of what we were just discussing before we started this proof, the previous note. Because if f is continuous at g of a, as we've assumed, that's the same as saying that it's continuous at the limit of g of x. Why is that the same? It's the same because we started by saying that g is continuous at x equals a. And again, what does it mean to be continuous? For g to be continuous at x equals a just means that g of a is the same as the limit of g of x. So we just replaced g of a with the limit as x approaches a of g of x. That's where that came from. Well, that implies that our previous note that we were just discussing applies in this case. The limit of f of g of x is the same as f of the limit of g of x. So we just showed that we were able to apply that previous note. And that validates the equal sign above. So let's continue. That f of the limit of g of x is equal to f of g of a. Okay, let's wait a second. There's got to be a reason for this. Let's describe it. The reason this is true is because g is continuous at x equals a. We said that at the beginning. That was one of our assumptions. So we're replacing with the limit as x approaches a of g of x with what it's equal to. It's equal to g of a because of continuity. Well, what is the definition of f of g of a? It's defined to be the composition f composed g of a. And we're finished at this point because we started with the limit as x approaches a of this crazy function f composite g, and we showed that it's equal to f composite g evaluated at a.